Father, we thank you for your magnificent universe. We thank you that you have placed us in a position where we can observe it and study it. I ask that this evening you would bless us with even more knowledge of your immense power, the size and the scope of the universe that you have created. In Jesus' name, amen. So, welcome this evening. We're going to be talking about the heavens declare. And that comes from Psalm 19. The heavens declare the glory of God, and the firmament shows his handiwork. Day unto day utters speech, night unto night reveals knowledge. There is no speech nor language where their voice is not heard. So I'm going to start off. We're going to be talking about physics and astronomy, but I'm going to start off actually. Excuse me, my machine went to sleep. You can edit this out. Right? Just have to wake it up. Okay. Physics and astronomy, and the first thing I'm going to show you, maybe not in that category, but it's close enough. And it kind of comes from another presentation I do called Science in the Bible, where we look at all these examples where God has put things in the Bible anywhere from hundreds to thousands of years before we discovered them. Okay? First example, Job 26:10. He drew a circular horizon on the face of the waters at the boundary of light and darkness. Proverbs 8:27. When he drew a circle on the face of the deep. Both of these refer to the Terminator, not Arnold Schwarzenegger. Terminator is this line on the face of the deep, and it looks like that. Germany is in the dark. And you can see the west coast of Africa, Spain there, and England and Ireland, still daylight. This description in Job and in Proverbs is a perfect description of what we actually see. And you'll see the lights of the cities to the right side there over in Europe where it's already dark. And I don't know for sure, but I'm guessing that neither Job nor Solomon was up in Skylab or the International Space Station or an Apollo capsule. How do they know what this looks like, and yet they're describing it in exact detail? All right. Now I'm going to move on to, as we go through this evening, there's going to be several things here that are downright shocking and scary. And, if there's young kids in here, might need to hold their hand. I don't know. First thing we're going to talk about is the leap second. Have any of you ever heard of this? This is scary business. Do you know that the earth is slowing down? It really is. There's an article normally every year in the paper. I've got some of this from the Toledo Blade from a number of years ago. There'll be a little thing on December 31st, probably on the front page. And it says, think you've had a long day? You're right. Why is that? There have been 24 leap seconds added in the last 36 years. 2/3 of a second per year, or 0.001825 seconds per day. New York Times rounds off the Earth's rotation slowing about 0.02 of a second per day. That ought to scare you, okay? We are winding down. Now, at that rate, 6,012 years ago, Adam and Eve would have had about a 23-hour and 53-minute day as measured by your Timex, okay? Not a big deal, right? By Adam's death 930 years later, the days would have been about 10 minutes longer. Not a big problem. However, if we go back 129,597 years, the Earth would rotate every 2 seconds. Okay? Poor soul living at the equator is hanging on for dear life at 45 million miles per hour. All right? That's only 129,000 years ago. And tidal and wind effects would have been beyond severe, thousands of years before that. The Earth would have flattened to a disk because of that. It's slowing down. It was faster in the past. You just work it backwards. And boy, oh boy. Now we know, really, prior to the Earth flattening, anything that wasn't really nailed down would have been ejected into space. So now we know what happened to the dinosaurs. All right. So, leap seconds, not a problem for God's time scale. 6,000 years, not a problem. I know I mentioned this last month. I'm probably going to mention it more than once tonight. And you're going to be bored to death for the number of times as you hear me talk about it. We cannot comprehend millions and billions. Our brains don't handle that. You read about it in the paper, you say, okay. But if you actually dig in, it becomes ludicrous. When you start looking at these things and you start putting the numbers to it, it does not work. And it does not work by a lot. Not even close. Not even close. So just the fact that the Earth is slowing in its rotation tells us you can forget the billions of years in terms of age. Okay, let's talk about the rate of decay of the Earth's magnetic field. This is another scary one. I bet you didn't know this was going on. The Earth's magnetic field is weakening. It's got a half-life of about 1,400 years, which means 1,400 years from now, it will be half as strong as it is today. It declines at about 5% every 100 years. This allows for a maximum age of the Earth of 20,000 years. Because you see, the Earth would be so hot it would just melt if the magnetic field was that strong. So you can't go anywhere near the billions. It'd be too hot, little or no water, no life possible. It would have been 20 times stronger 6,000 years ago. 50,000 years ago, not 4.5 billion, 50,000 years ago, it would be 56 billion times stronger. Of course, we couldn't go that far because, like we said, at 20,000 years, the Earth would have melted. So again, these numbers don't work. Now, the magnetic field, and I think you saw this on the video, on the left is the sun. It sends out some bad stuff, okay, some radiation and particles, and the Earth's magnetic field deflects that and protects us from that radiation. It was 20 times stronger back in Adam and Eve's time. This could be one factor, certainly not the only one, it could be one factor in why we see these patriarchs back then living to be 900 years old. They didn't have all that radiation that we're getting today. And 1,400 years from now, we're going to get half that much strength in the magnetic field, which means we're going to get more. So we go to Isaiah 45:18. For thus says the Lord, and then there's a bunch of stuff in between, I am the Lord and there is no other. So now I'm going to read you the stuff in between. For thus says the Lord, who created the heavens, who is God, who formed the earth and made it, who has established it, who did not create it in vain, who formed it to be inhabited. Earth is formed to be inhabited. Is it an accident that we have a magnetic field that protects us from these things in the sun? Or did God make it that way to protect us from those dangers? Okay, let's take a look at the future of the universe, two different views. First one, the Big Bang future of the universe. On the left, in the beginning was nothing, which then exploded. Yes, I'm making fun of them, but that's not my quote. That's a quote from an evolutionist. That's what they believe. In the beginning was nothing, which then exploded. Billions of years of time, and eventually a heat death. And what do they mean by that? Well, we're going to get into this more a little bit later here with the physics, but the total mass and energy in the universe is constant. You have, and you measure like energy with temperature. So you've got high temperature, low temperature. So the difference between these is how you can get useful work accomplished. Over time, that energy is being exchanged. If you have a cup of hot coffee here and you drop an ice cube in it, the heat is going to exchange, the cube's going to melt, the coffee's going to get cooler. If you leave it here long enough, that cup of coffee is going to be room temperature, right? Because that's all going to equalize. And that's what they're saying about the universe. When all that settles out, the total energy is the same. That has not changed. The useful energy, zero. The universe suffers a heat death. There's no more heat exchange. That's the Big Bang picture. That's a secular model. The biblical future of the universe is a little different. Instead of the Big Bang, we've got six-day creation, thousands of years. Then what happens? 2 Peter 3. The earth will melt with fervent heat. God is going to judge the earth. Then the new heavens and the new earth, and then eternity. Two different pictures here, one based on the Bible and one not. Now, the earth is going to be destroyed by heat according to Peter, and there's other scriptures in the Bible that tell us that. We know from last month it's not going to be a flood, right? Because God said, I will never do this again. I will never destroy the earth with a flood again. But I don't know, did he have his fingers? But the Big Bang's a coming. It's not behind us. Big Bang is yet to come. I will destroy the earth with fire. And we can get that out of Scripture. So two different views based again on your religious worldview. We're going to look now at the secular model of cosmology. And they've got a number of points here. The entire universe is contained in a point. That's at the beginning. Now that's contradictory. In the beginning it was nothing, but then all of a sudden there was this point, like a period. And if you can imagine like the entire earth compressed into one point, that's kind of dense, wouldn't you say? How about the entire universe condensed into one point? And then we have the Big Bang, and things rapidly expand and cool. Point rapidly expands like a balloon and cools. Number 3, energy becomes matter, hydrogen, helium, and lithium, initially, the light elements. Matter condenses into stars and galaxies. Stars create heavier elements, which become dust. The dust condenses to form planets. Now, of these 6 items here, which of those would you say is scientific, that is observable and repeatable? Pretty much zip. We're going to see number 3 there. Yeah, we can repeat that in a small way now. We'll talk about that later. But basically, this whole thing, again, is a kind of a faith statement. It is not science, guys. It's not observable, testable, repeatable. It is not. Okay, 3 possibilities for the origin of the universe. Big Bang. The eternal or steady state. Now, these are the folks that say the universe has always been here, it will always be here. Throughout eternity, nothing changes. That was the predominant view prior to, maybe the 40s or 50s or something, when this other idea came about. And actually, there's a astronomer, British astronomer, Sir Dr. Fred Hoyle. And he was an eternal universe, steady state guy. And when these guys came up with this idea, he gave it the name, and it was in ridicule. It's a Big Bang. And so he gave that name to ridicule it. Well, the name stuck, and now they wear it with pride. Yeah, we believe in the Big Bang. That's how the universe got. And sadly, many Christians jumped on that and said, wow, they're not saying the eternal universe anymore. They're saying the universe had a beginning, and that's what my Bible says, so I'll go with that. We don't even have time to get into this tonight in detail, but Big Bang is not biblical, okay? You can say that's common to say there's a beginning, but that's as far as you can go. Okay, and then of course the third, in the beginning God created. 3 different possibilities. Now, as we look at science and some terms here, there's one called hypothesis and theory and then law. Now, hypothesis is kind of like an idea. Well, I think if we do this, this will happen. So what do? You test it. I do this. This happens. Great. Or it doesn't happen, you throw your idea away. If it does happen, you test it again. And you test it again. And you get, pretty soon, if you get a bunch of these hypotheses together, formed into something that you can call a theory. And this then becomes a scientific theory. I'll pause here. I don't think I mentioned this last month. Might have. Sometimes people will say, well, they claim that evolution is a fact, but it's just a theory. It's only a theory. Please don't give it that much credibility. Evolution does not even qualify to meet the basic threshold of being a theory. A scientific theory is a very rigorous thing. And so evolution is an interesting idea that has no evidence, but not a theory. Anyway, we have hypothesis, we have theory. Now, there are several theories about science that are out there. The next step up is law. There are not many laws, because if your theory holds up and you test it over and over and over again and there's never an exception, and you can't imagine an exception, and it really stands the test of time, then they call that a scientific law. So let's apply some laws. By the way, one example of a scientific law is the law of biogenesis. Life comes from life. And someday I'll share with you a textbook I have, a college biology textbook, and it's right there in the first few pages. The law of biogenesis. And, who's that guy? Louis Pasteur, I think, came up with that one. And they expand on that right there in the first few pages of the book. And then when you get to the back of the book, they're saying life spontaneously evolved from non-living goo. And so, well, wait a minute, what happened to the law that was in the front? So, but there's some other laws here. And one of those is the first law of thermodynamics, the law of energy conservation. It says energy can be converted from one form to another, but it can neither be created nor destroyed. So, and Albert Einstein helped us with that. E equals mc squared, there's a relationship. But it's the law of conservation of mass and energy. And what does that do? It rules out the Big Bang. The universe cannot create itself. There is a fixed amount of total mass and energy that can change relatively, and that's his formula. And the m is mass. The c is the speed of light, which is pretty big, squared. So you take a little bit of mass times the speed of light squared, you get a lot of energy. It's called an atomic bomb. Okay? Likewise, you can apply a lot of energy to a little bit of mass, or to a lot of energy involved to produce a tiny little bit of mass. But this first law of thermodynamics rules out the Big Bang. Can't happen. Let's move on to the second law of thermodynamics, the law of energy decay or entropy. The way I like to phrase it is eventually everything turns to poop. If you take your 57 Chevy and put it up on blocks in the backyard and come back 40 years later, is it going to be a shiny new Mercedes? It's going to be a pile of rust, isn't it? So we know how this works. The energy available for useful work in a functioning system tends to decrease, even though the total energy remains constant. Total's constant, but for useful use, this is this heat death of the universe we're talking about. The organized complexity or order of a structured system tends to become disorganized and random. You are all familiar with this. You clean your child's bedroom spotlessly. How long before it becomes disorganized and random? Okay? This is the way of the universe, all right? The second law of thermodynamics is not violated. Information conveyed to a communicating system tends to become distorted and incomplete. So, this rules out the eternal or steady state universe, because you see, eternity is a long time. So if the universe is winding down, then at some point, if it's eternal, you see it winds down and it's gone, it's already done. So it rules out the steady state or eternal universe. Cannot happen. Second law of thermodynamics says no. Let's see, that leaves us with one. What was that? In the beginning, God created the heavens and the earth for the origin of the universe. That's the only one that fits. All right, let's take a look at the law of conservation of angular momentum, another law. And to do that, we're going to take a peek at the sun. Oops, how did that get in there? I got a better picture than that. Okay, there's the sun. The sun has 99% of the mass in our solar system, and yet only 1% of the angular momentum. This is not normal. This is not natural. This should not happen. If the universe created itself, we've got this, it follows the laws and so on. This cannot be, absolutely cannot be. And yet, there it is, 1% of the angular momentum and 99% of the mass. Likewise, when we're looking at angular momentum, when you're talking about these ideas of how the sun forms and the planets form, and they say this nebula contracts and it's spinning around, and the sun kind of gets together there and starts producing heat and so forth, and then the dust particles are doing the same thing, and they've all got this same revolution. And we know that the Mercury and the planets, go around the sun pretty much the same way, and you expect that the moons also go around the planets like that, and they do, except for the ones that don't. We've got a couple of satellites, moons of other planets that go the other way. I think God did that just to confuse the evolutionists. I mean, there's no explanation for it. Should not be that way. All right, let's take a look at the Poynting-Robertson effect. This is, I'm sure, named after Mr. Poynting and Mr. Robertson. Basically what it is, the sun acts like a giant vacuum cleaner. 100,000 tons of micrometeoroids per day it sucks in with its gravitational pull. 100,000 tons of micrometeoroids that the sun is pulling out of the solar system. For the tiny little particles that are smaller than that, the sun's radiation pressure is pushing that away, pushing it out of the solar system. This combined effect of house cleaning, at the present rate, would have cleaned house in 10,000 years, actually less than 10,000 years. The solar system should not have any of those particles in it because of this Poynting-Robertson effect. And I verified this at the ICC conference. Every time, I'm with some of these astronomers, I ask them, is that still a valid? Oh yeah, it is. And so how can our solar system be billions of years old when we've still got the dust out there? And the proof of that, if you've ever been to the NASA museum or these places where they have the space capsules, and they've got the plexiglass and you can see the little pock marks there where the dust has hit it, it's still out there. There's plenty of it around. So how come this vacuum cleaner hasn't done its job if it should have cleaned out in 10,000 years? And the fact is we haven't been around that long. All right, Poynting-Robertson. Now let's talk about starlight and time. And this is one you're probably all familiar with or have heard about. Well, if this star is 2 billion light years away, by the way, that's a measure of distance, not time. But logically, you would say if the light comes this way, it would take that long to get here, so how can we only have a 6,000-year-old universe? So this is a problem, but it's a problem for everybody. It's called the horizon problem for the Big Bang folks, for the evolutionists, all right? Basically, in the Big Bang model, you've got, they're now saying, 13.7 billion years for the age of the universe. So it can get out to here, and you can have an energy exchange up to a certain point. And the only problem with it is that the universe is determined to be 92 billion light years in diameter. So they have the same problem that creationists do with this starlight time travel, and nobody fully understands it. We know that we don't understand it, but for someone to say, well, this destroys your creation timeline, that's not true, because it destroys their timeline also. There have been a number of propositions made, and the first one here, light created en route or the mature creation. This one was favored by Dr. Henry Morris early on. I don't know if in his later years, if he still favored that or not. And the idea of the mature creation, well, he creates these stars, and while he's at it, he goes ahead and puts the light beams in there, so they're already in place. So, and that sounds kind of good, but every creation scientist and astronomer that I know does not accept that. They don't think that's valid because, in a sense, God would be misleading us. Because when we look out there and we see that supernova that supposedly exploded so many years ago, whether it's millions or whatever, and in fact it never happened, he just put the picture in a way. So they're not too keen on that particular one. The second one is the speed of light in the past was greater. This is called sea decay. And this was put forth primarily by Barry Setterfield, but some others. And there were some measurements, I don't know, 10, 15 years ago as they're scoping this out, that seemed to indicate the speed of light was slowing down. So, but they've done more measurements since, and it seems like, well, maybe not so much. And even if it did a little bit, it's not nearly enough to account for these distances. So that one is not really favored by anyone today, I don't think. Very few people. That the speed of light was so much faster before, and it slowed down. That doesn't seem to work. The third one, gravitational time dilation, or white hole cosmology, is put forth initially, I think, by Dr. Russ Humphreys and also Dr. John Hartnett down in Australia, just as a kind of a modification. And that one I really don't have time to go into in detail. It has to do with Einstein's theory of relativity. And basically, the basic facts we know are true. Gravity affects time. So that a clock in Death Valley runs slower than a clock in Denver. There's a mild difference in altitude. Gravity is stronger. Gravity affects time. In fact, they have to take that into account. Most of you probably use one of those infernal GPS machines. Recalculating. You turned the wrong way. That would not even work if they didn't account for this gravitational effect, because that satellite is a lot higher than Denver, okay? So when they're doing these GPS calculations, the timing has to be adjusted for the fact that that clock up there is running faster than the one on the ground. So they have, even it's a small amount, but they have to adjust for it if they're going to give you accurate geographical information on your GPS. So that part we know. And Russ Humphreys' model, talking about the beginning where God is expanding the universe, and in the beginning you've got this very deep gravitational well with the earth at the center, and as he's expanding that out, it's entirely possible for the stuff out here to be billions of years time elapsed, while the stuff in here is only thousands. So it's a very interesting model. As far as I know, no one has refuted that successfully. And he's been tweaking it as time goes by. And another newer one that's come out is Anisotropic Synchrony Convention, or ASC, put forth by Dr. Jason Lisle. And I believe Dr. Danny Faulkner is also kind of coming on board with this one too, from what they were saying at this conference recently. And the idea here is a couple of ways of looking at it. One way Jason Lisle explains it, if you get on a plane in Columbus at 9 o'clock and fly to Chicago, and you get off the plane at 9 o'clock, so kind of different time zone kind of thing. And it has to do, again, with Einstein's theory of relativity, as they're using the calculations. And Jason Lisle admits, this is his idea, he admits it is not intuitive. It doesn't sound logical, but the math and the physics work fine. Says and he starts, all these guys, they start with the scripture, with the Bible. What does the Bible say? And then they move on from there. And so basically he's looking at it with the mathematics, is that the light coming at us, instantaneous. The light going back is half as fast as what we measure. So you say, well, how can that be? Well, we don't know the speed of light. You say, sure we do, it's 186,000 miles per second. No, that's measured on the two-way speed of light. We send a beam out to a reflector of known distance, it comes back, we measure it. We know how long it took to get there and get back. It is impossible to measure the one-way speed of light. That's a Nobel Prize winner if you can figure it. Cannot be done. So, it's okay to have it instantaneous one way, half as fast the other way. You add that together and you get the 186,000. And they went through a bunch of stuff, calculations. Diana understands all of it because she was listening. You can ask her. This having to do with the special theory of relativity. And so, but they're interesting ideas, and who knows if one of them is correct or not. We may not know this side of heaven the exact answer, but the point is, it's the same problem for the Big Bang, folks. It's not a deal that shoots down the creationist ideas by any means. And we talked about expanding universe. You've probably, I'm sure, read articles in the paper that most astronomers believe that our universe is expanding. Okay. Now, they could have figured that out had they read Isaiah 42:5. Thus says God the Lord, who created the heavens and stretched them out. And you say, well, Steve, you can't expect these guys to find one verse in the Bible. Okay, maybe one of the other 16 would have helped out, because there's 17 total in the Bible that tell us that God stretched out the heavens. You know, so, and they're telling us that's what they're finding. So that should not be a big surprise. Now, these next three, I am sure you have been losing sleep over this, and they're pretty big deals. The quantized redshifts, monopole problem, and the baryon number problem. Now, has that been keeping you awake at night? Yes. I thought so. Well, let me put your mind at ease. The monopole problem, we'll start with that one. Magnets have two poles, right? North and south. But there is something called a monopole with only one. I don't understand that. But the Big Bang scientists tell us that in the beginning, with this Big Bang, the intense heat was so great that it would have produced gobs of monopoles. I mean, they ought to be everywhere. And they are stable, which means they last over time. We ought to be able to find them. The only problem is we can't find any. None. So the monopole problem refutes the Big Bang. The baryon number problem. Okay. Basically what that's talking about, if you can back up, a few slides, and we were looking at E equals mc squared, and we say that if we apply a lot of energy, we can produce a small amount of matter. And this has been done in the laboratory. Very small, but it has been done. It can be repeated. And in every case, without exception, what is produced is an equal amount of antimatter. Matter? What's antimatter? Well, I don't know really, but I know what they tell me. The charges are reversed, so instead of an electron being a negative charge, you've got a positron doing that. And in the nucleus, instead of a proton, it's a negative charge. Okay? Matter, antimatter. Every time experimentally, and when you do the physics, how this would happen in the universe, you should produce an equal amount of matter and antimatter. And yet, where is the antimatter? Over here on the left, we see equal matter and antimatter. Over here on the right, there's hardly any been detected, practically none at all. This is a good thing. Do you know what happens when matter and antimatter come together? Poof! Annihilation. Aren't we lucky? Or did God create it that way? A universe that's not 50-50 so that we're bumping into each other and annihilating ourselves, okay? Baryon number problem is a big problem for the Big Bang. Shouldn't be that way. All right, what was the other one you should be scared about? Quantized redshifts. You've probably heard about redshifts. This is talking about the spectrum. It's somewhat similar to the Doppler effect. If you're waiting for the train to come and he's tooting his whistle and the train's coming at you, the whistle sounds higher coming toward you. And as he goes away, it sounds lower. And that has to do with the speed of sound. Okay, light the same way. And you say, yeah, that's why cars coming toward me have white lights and the ones going away have red lights, because it's... No. It's because the taillights are red. All right, because trains and cars don't go anywhere near the speed of light. But when you get up to the higher speeds, then this spectrum of light is also shifted. And it's shifted toward the red when they're going away from you and toward the blue coming toward you. So it's been known, these redshifts have been studied. But in recent times, what they've discovered is quantized redshifts. What does that mean? It means they're in bundles or clumps. They are in concentric shells, okay, with gaps in between. So this is not normal. This is not natural. This is not Big Bang. This is design. Quantized redshifts. What else do the quantized redshifts indicate to us? And this is fairly recent stuff now. As you measure it looking all the way around, most people don't realize that the Big Bang, the whole picture of the Big Bang, number one, there is no edge to the universe. Number two, no matter which way you turn and look, it looks the same. Every direction, it's the same. That's required by the model. Well, the quantized redshifts are telling us that from where we sit, the Earth is very near the center of the universe. Now, what of the Carl Sagans of the world? If you, you're all old enough to know Carl Sagan, and the Big Bang folks. What do they tell us? That we are an inconspicuous speck, the Earth, in a dark corner of the universe. We're nothing special. Okay. Now, Scripture does not require that the Earth be at the center of the universe. Doesn't have to be at all. But it certainly wouldn't deny it. All right? So when we find out from this latest study here, from the quantized redshifts, that the Earth is very near the center, we can accept that. When I say very near, imagine there's a big target up here, and here's the bullseye. The Earth is in the bullseye. Our measurements are not accurate enough to say exactly where. Might be dead center for all we know, but all we know is it's within this area here. So, and when I say near the center, like 100 million light years or something, which is nothing compared to 92 billion across the... So, as near as we can measure, we're close to the center. Not upsetting to a creationist at all. And, but again, the Scripture does not require that. Well, let's take a quick look through some of the planets here. This is Mercury. That's kind of pretty. You wouldn't want to live there. Very hot. Very quickly. Evolution says it cannot be dense, but it is. It can't have a magnetic field, but it does. The half-life of the magnetic field on Mercury is 320 years. What did I say Earth was? 1,400? Every 320 years, the magnetic field shrinks to half in Mercury. So, and we measure yet today, and it's pretty strong. What does that tell you? It hasn't been around for billions of years. The volatile elements that it has there discredit that solar nebula model. It looks young. Venus is, the surface of Venus actually appears young. It is different from the Earth in many ways. It's way too hot for life. Venus is actually much hotter than Mercury because of the old greenhouse effect that we worry about. The scientists are telling us, oh, we got global warming. Nonsense, we're just coming out of the ice age. We're just slowing down as we complete that process. But also Venus has a crushing atmospheric pressure, not good for life. God did not design it for life. Earth really should have little or no water, but we're all 75% or 70% covered in water. Magnetic field is young, uniquely designed for life. We talked about the magnetic field earlier. It's important for us, and it's way too strong to be 4.5 billion years old. Can't happen. We're going to look at that again at some other planets. Let's take a look at Mars. And liquid water really not possible as we look at it today. Very little atmosphere. The gravity is not enough to hold an atmosphere. As we talked about last month, they speculate there was a global flood on Mars. There might have been. They're perfectly willing to call that a flood of biblical proportions on Mars where we can't find any water, and totally reject that we had a total flood on Earth, which is 70% covered in water. So go figure. The landscape is not particularly inviting, but I guess there's people signing up to go there. I don't know. Okay. Jupiter Evolution says it can't be made of the materials that it has. Ganymede should not have a magnetic field, but it does. That's one of the moons that they've measured of Jupiter. Callisto shouldn't be geologically active, but it is. Europa disproves the long-age crater counting. Io looks young. These are all moons. All the Jovian planets, that's from Jupiter on outward, are way too hot. They should have, if they're that old, Jupiter is still putting out more heat than it takes in. And this cannot be if we're talking about billions of years. Saturn, same thing. Moons are young on Saturn. Now I've got several pictures here because Saturn's so pretty. And this next one, they've changed the colors. It doesn't really look that way, but they put the colors in to show the different materials that are in the rings of Saturn. But the bottom line is that those rings are young. They are already dissipating. While you make up tomorrow, they might be gone. Maybe not that soon, but they're not billions of years old. Okay, they are disappearing. Uranus, here's an interesting planet. We've got the sun here, and we've got all these planets that go around like this, and as they're going around, they rotate, you know, the Earth and Mars and all those like that. Guess what Uranus does? 90 degrees off. It rotates just it likes that. And this is not normal. This is not natural. Again, I think God did this just to confuse them and confound them because you can't expect to find that. Now, let's talk about the magnetic field. Back in 1984, Dr. Russ Humphreys, in studying some of the work that other folks had done on the Earth's magnetic field, he did some projections on these outer planets. He says, okay, Uranus, for example, if it's really only about 6,000 years old, should have still a pretty strong magnetic field. If it's billions of years old, it should have a very weak. Right? This is not nitpicking, okay? This is orders of magnitude, huge difference, okay? Now, he put that in writing, put it down on paper. It's a projection, okay? It's a prediction. He had to wait 20 years. 20 years until Voyager made it out there. Or for you Star Trek fans, V'ger. Okay? And what did Voyager find when he measured the magnetic field of Uranus? That it was 100,000 times stronger than the evolutionary prediction. And in the chart that Russ Humphreys had put out, and it's not just one line, it's the typical line with error bars, okay? So he's got this, it's going to fall within this range. And that magnetic field, when they measured it, Uranus, when they got there, smack dab in the middle of his predictions. Uranus at about 6,000 years old, based on the magnetic field strength. Neat stuff. Pluto, poor Pluto, you know, got demoted. Turns out there's a lot of what they call trans-Neptunian objects that's beyond Neptune that are probably as big as Pluto. But even what they know about Pluto, very low on craters. If it's that old, should be a lot more craters there, not there. But we skipped one. Let's take a look at Neptune. It's been known since 1972 that both Uranus and Neptune can't exist according to the evolutionary model. Magnetic field is also strong there. It generates energy, that planet. Has violent winds. Moons, all these moons out there volcanically active. They don't expect to find that. They're staggered when they find that. Not surprising to the creation scientists. I'm breezing through these quickly. I'll give you some resources at the end that you can get in more detail from people who understand it. Okay? On the left is the sun. Way over here on the right is the Earth, which is a dot that you can probably see. The moon, trust me, I can see it from here. There's a little dot there. You probably can't see it. What does that say? Well, the sun's a lot bigger than the moon. Actually 400 times bigger. But guess what? The moon is also 400 times closer. So they appear to be the same size in the sky, which is why we can have this magnificent eclipse that we saw last summer. Diane and I went down and parked in a little church parking lot in Tennessee, right smack dab in the middle of it. And the sun went dark. What are the odds that our moon is 400 times smaller than the sun, 400 times closer, and able to give us this eclipse that scientists can study and discover the corona and the sun and that sort of thing? The moon is unique. There are 163 moons in the solar system. None of them comes close to be able to produce an eclipse. Because guess what? There's nobody there to watch. There's no Martians, there's no Saturnalians, 163 moons, none of them are even close. The moon is very unique. It is very large in comparison to the size of the Earth that it orbits. Very unusual in the whole solar system, and the only one capable of producing an eclipse. The moon is the only other body in the solar system that's been walked on by man. 6 visits, 12 men have walked on the moon. It is still geologically active. Just the right distance for our tides that keep our oceans washed clean, keep life going. Just exactly the right distance. How do you figure? Now, there are several theories on how the moon came to be, because nobody knows. All right. Quickly, the nebular theory. This is kind of like how the stars form and the planets form. There's a bunch of dust out there. It comes together and makes itself into a big rock, and now you've got the moon. Okay, the nebular theory is a total failure on all counts, whether you're trying to make a star. I don't care what you read in the newspaper about, we've seen a star being born. No one has ever seen a star being born, period. They see things that may indicate, well, we think this happened. No one has observed that because, of course, it is impossible. Why is that? Well, this nebula, the gas is out here. Yes, there's some gravitational effect that might tend to draw them together, but you've blown up a balloon, and when you get that pressure higher as the gas is getting, the gas pressure is many times stronger than the gravitational force. So they don't tend to come together, it goes apart. You cannot have particles forming that way, whether they're stars or planets. Anyway, that's the nebular theory on the moon. The fission theory, or the daughter theory, is something comes along and bops into the Earth and knocks a bunch of stuff out, and it just happens to form itself into a sphere and orbit circular orbit. Okay? The capture theory, or the spouse theory. Here's the moon minding its own business, just going through space. Comes near the Earth. Okay, I'm going to take up a circular orbit, and here I am. And it's going to be just right for the tides and the eclipse and all that kind of stuff. And the thing is, when something comes in like that, and it doesn't take up a circular orbit, it takes an elliptical orbit. So for the moon to get into a circular orbit, it has to fire its retro rockets. Precisely. All right. So those 3 ideas that have been put forth for the formation of the moon, no matter which one of those 3 you support, if you're this guy, you say these 2 guys are nuts. Impossible, can't happen. And the fact is, they're all right, because they're all wrong. None of them work, okay? None of those are any good. Well, there is that other one. On day 4, God created the lesser light, and that seems to make a lot more sense. Okay, the moon, as I said, is pretty large. It's about the size of the United States, and that's the moon superimposed on the United States. Now, for the reverse picture, we're going to get the United States superimposed on the moon. A little fainter to understand, but you can see Florida down there, you can make it out. So, again, pretty good. Now this one, I've scared you before tonight, but you better hang on to your seats, because you're not going to be able to get to sleep tonight. Did you know the moon is leaving? The moon is leaving us. Not real quick, about 1.5 inches a year. Okay, so it'll still be there tomorrow, but there's a formula for that, and there's going to be a test later. Okay, so pay attention. Actually, I'm told this is not really a high-powered formula. It's basic Newtonian physics, all right? But what is it describing? It's called the recession of the moon. And here's what's going on. The moon is orbiting the Earth, and the moon has a gravitational pull, and so we can see these tidal bulges at the top and bottom. So we get a high tide twice a day, low tide twice a day. And that's because of the moon's gravitation. Well, as it happens, the Earth is rotating a little faster than the moon is orbiting, and so because of the effect of these tidal bulges, it's actually pushing the moon out. Again, it's a whopping 1.5 inches per year. And here we go again with these big numbers, okay? It's no big deal. At the time of Adam and Eve, the moon would have been 800 feet closer. What is it, 240,000 miles or something like that? Not a big deal. But now again, when we start applying these big numbers, what happens? Because as time goes by, the moon's moving farther away, so we go back in time, it was closer. What happens? Well, when it gets in not too far back in time and gets closer, because of the size and the gravity, now we have the Earth totally flooded twice a day. That's a high tide. Twice a day. Now we know what happened to the dinosaurs because you can only comfortably drown once per day. Right? Twice a day. So that's when the moon gets in closer. Now, when the moon comes in closer yet, it gets to what's called the Roche limit, R-O-C-H-E, probably named after Bob Roach or somebody, R-O-C-H-E. The Roche limit, which is, in our case here, is about 12,000 miles. When the moon gets in that close, it explodes. Why is that? Gravity acts as to the square of the distance. Because the moon is so large, there's such a big distance between the near side and the far side, when the moon gets to the Roche limit, the gravity of the Earth is so much stronger, so many times stronger on the near side than the far side, it just rips it apart, and the moon disintegrates. But let's say he puts up his force shield and gets by the Roche limit, okay? Then we've got a case where the moon would actually be touching the Earth 1.5 billion years ago. This does not work. How can we have both of them 4.5 billion years old when only 1.5 billion years ago they're touching? Does not work. Of course, they would never touch because, again, if it were, you go back in time, you hit the Roche limit, it would be destroyed. So, as it happens, it's not a problem for the biblical timescale. Not a problem at all. You cannot put the billions of years to that and make it work. Okay. Boy, can you imagine Adam and Eve? Look out, there it goes again. You know. Whew! No, can't have it that close. Won't work. All right, let's talk about comets. You know what a comet is? It's a dirty ice ball. As these come in elliptical orbits into the solar system, come around the sun, go back out again. As they get near the sun, starts evaporating, forming this tail, which we can see. And you've probably heard, when I was growing up, I was reading about Halley's Comet. And back in the 1800s or something, man, how spectacular this was. And I think it comes by maybe every 85 years, I can't remember. What's that? 75. 75, thank you. You're good at this stuff, okay. Every 75 years. So remember, what's it been, 10 or 15 years ago? Halley's Comet was coming. Whoa, I can't wait. It goes by, you know, gee, that wasn't such a big deal. Why is that? Well, on every pass, the sun is burning up large parts of it. Dr. Jason Lisle, astronomer, who's especially got his PhD studying the sun, he actually has seen a comet disappear. It goes around the sun, it never came back because it had gotten to the point where by the time it got around, it had all burned off. Why is this important? Well, these comets cannot possibly last more than 10,000 years. Can't happen. How can our solar system be billions of years old when the comets are still coming and going? You know, and what's the secular scientist's answer to this? Well, it's one of Diana's former countrymen there, a Dutch guy named Oort, O-O-R-T, and he proposed that there's a cloud out there which is called the Oort cloud. Got it named after him. It's just outside Pluto, maybe somewhere we can't see it, but its job is to be a comet factory and generate new comets and spit them out, you know, so that's why we can still see comets, because we're still manufacturing. The only problem with that is no one has ever found the Oort cloud. It doesn't exist, okay? Only in his mind, it's not there. It doesn't work. Comets are a big, big problem for the billions of years. Two other ones here are blue stars and spiral galaxies. Blue stars are found, a lot of them are found in spiral galaxies, but blue stars are exceptionally hot, much hotter than our sun. They burn fuel like crazy. They burn out early. They cannot last billions of years. And yet, we see lots of blue stars. Why are they still there if they're supposed to be that old? Got a lot of them. Spiral galaxies. They're pretty. We live in one. The Milky Way galaxy is a spiral galaxy. I'm sorry, John, can you see that? I've been standing here the whole time. Okay. Spiral galaxies, very, very pretty. Okay. So what's the problem with spiral galaxies? The stars near the center of the galaxy, they rotate differentially. The stars near the center rotate faster than the ones farther out. Why is that a problem? I'm going to show you a sequence here. By the time you get down to picture number 4, not recognizable. Where is your spiral galaxy? Gone. How long does that take? Why, practically a heartbeat. Less than 100 million years. Okay? Now for us that's a long time, and it really is. But the point is, if these things are supposed to be 10 billion years old, and the spiral shape can only last less than 100 million years, that's a big, big difference. We should not be seeing any of those. Should not be there. And the farther they look out into space, which these are supposed to be things that are supposedly even much older and earlier in the Big Bang model, and finding, the spiral galaxies even out there. Can't be. Will not work. All right. Everybody got a headache about now? All right. Well, we're done. But I'm going to show you some resources. This is a book called Starlight and Time by Dr. Russ Humphreys. It's divided in half. The first half is for you and I. And it explains his gravitational time dilation, the white hole's cosmology. The second half is for physicists. And there's a lot more formulas and math and all that where he proves what he's talking about in there. And I read through that too. It just didn't come through as clearly as the front half. There is also a DVD by the same title. And he has updated that recently. There's a new one that I just showed to our group in Toledo last month called Light Years? No problem. And it's kind of an update to this model that he has. And so those are excellent resources. Let's see, we've also got this one, Taking Back Astronomy by Dr. Jason Lisle. And that's this one right here. Talks about a lot of these things in here. Pretty easy to understand. It's a layman's version. Dr. Danny Faulkner has this one, Universe by Design, which has been around for a little while. Very well done. He's got some newer ones. Let me see what I've got here. I think he's got one called The Created Cosmos. Does that sound right, Alex? Oh, Alex? Does Danny have one out called now The Created Cosmos? Yeah, okay. That's the book. There is also a DVD, which is the title of one of the planetarium shows at the Creation Museum, The Created Cosmos. Really well done. It's not connected with Danny Faulkner. He just happens to have a book by the same name that has just come out. See, Design in Astronomy. I forget who did that one. Then there are some DVDs. There's a series, a 3 DVD series, What You Aren't Being Told About Astronomy, with Spike Basaris. He was a engineer with the U.S. military space program for many years. He went into that program as an atheist and came out as a Christian and a young earth creationist. And it's an excellent series in 3 DVDs. The Heavens Declare is a 2 DVD series, which is a panel of astrophysicists that are covering different topics, and very new, very well done. Okay, I talked to you last month about the Answers magazine. Have you all subscribed? How many? You subscribe, right? No, who was that? Somebody has a subscription to Answers magazine. Maybe they didn't come this month. Okay. Fantastic magazine. Comes out every 2 months. You can't put it down. It's not strictly creation evolution. It's apologetics topics in addition to that, but primarily creation evolution debate. That's where the battle is. And there's a section in the center for younger kids that goes along with the theme. And like I mentioned last month, it's popular all the way around the world. And so I can recommend it very highly. I used to say, go ahead and subscribe, and if you don't like it, I'll give you your money back. I did that for 15 years or so. Nobody ever asked me for the money back, so I quit doing that. But it's fantastic, absolutely fantastic magazine. Okay, thus ends our tour of space. Boy, thank you all for coming out tonight. And bring 10 or 15 buddies next time in September. We'll find more chairs. We'll make it work. Remember, next time, the dating game. But we're not talking about romance. How do they know how old something is? You'd be surprised and probably delighted, because we're going to find out that when they spew these numbers out, they are not reliable. But fortunately, we have an eyewitness who wrote a book. This is what I did, and this is when I did it. And when you start here, as you're looking at all these things, you come to the right answers. You find the right answers. If you have a different set of glasses on, different filters, then you've already rejected the Bible out of hand. There is no God. We're going to explain the universe without him. So we got to come up with a bunch of accidents over a really long time, and pretty soon you're not being scientific at all. You're not being objective at what you're looking at. You see something you don't like, you throw it away, because it does not agree with your worldview.